These are your 10.5b notes, the distance formula. We are going to discover the distance formula using the Pythagorean theorem. So really quick, when we talk about distance in math, we're really talking about the length of the segment. We're talking about from endpoint to endpoint. So I have a picture here on the coordinate plane. There's actually distance just on the number line, and you'll talk more about that in geometry, but we're going to concentrate just on the coordinate plane. And so we would be talking about how long is that line segment between P and Q. And so the distance between P and Q cannot be negative. You cannot have a negative distance. Even if I'm driving in my car, if I go forward a mile or I drive backwards 3 feet, the negative, just because I'm going backwards does not mean it would be negative. The distance traveled would still be 3 feet. So sometimes we use negatives for direction, but the distance itself cannot be negative. And I just want to stress that sometimes they may not say they're looking for the distance. They may ask us to find the length. And so it's just another sneaky way for them to ask for the distance. So if you look at these two ordered pairs here, P and Q makes a line, and it'd be a lot easier if it was just straight across or vertical. So I allow you to count when it's just a vertical or a horizontal line. You can actually just count the length. But when it's on a diagonal, you can't really say how long that is. So what we have to do is we're going to bring in Pythagorean theorem. We're going to treat that as the hypotenuse of a right triangle. And so what I created here is just another point R. So I'm going to call it P, Q, and R. And R happens to be where my right angle is. And we can actually then count our horizontal and our vertical distances. So I know that the distance between Q and R is 1, 2, 3 units. And I know that the distance between P and R is 1, 2, 3, 4, 5 units. And so I could use the Pythagorean theorem to actually figure out the distance in between that P and Q using Pythag. So I could say a squared plus b squared equals c squared, or 3 squared plus 5 squared is equal to c squared. 9 plus 25 equals c squared. That's 34 is equal to c squared. And so when I take the square root, that value there is the square root of 34. And so the length here would be the square root of 34. When I check that on my calculator, the square root of 34 is actually just under 6, or just over 5, I guess, if you would. So it is the largest. It's 5.8. So it is the largest segment there. What I'd like to do, though, is that was great for this particular point, but what if the points were further apart? I wouldn't want to have to count on the coordinate plane. So what I'm going to do next is we're going to use the Pythagorean theorem, and we're actually just going to use these ordered pairs to help us figure that out. And so when you do that, I can have, I have some coordinates here. And so, give me 1 second. Okay, so what I can do is I can actually write the ordered pairs here, and I could write the ordered pair of Q as 1, negative 2, and I could write the ordered pair of R as 1, 2, 3, 4, negative 2, and I could write the ordered pair for P as 4, 3. And you can sort of see where these numbers are coming from. You can see where I'm getting the 5. The 5 is found by finding the difference between these two ordered pairs, or that vertical distance. So that would be the difference between the two y values. So 3 and negative 2. If you take 3 and you subtract negative 2, you get 5. That's how you found that length. And then to find the distance here of 3, you can notice that that's your horizontal distance, and that would be the difference between 1 and 4. And it has to obviously be the positive, and so it's got to be 3, not negative 3. So I can actually find those distances. I don't need the ordered pairs necessarily. I can use actual coordinates. So instead of using numbers 4 and 3, let's just call this first ordered pair x1, y1, to represent the first order pair for P. And then for Q, I'm going to call that X2, Y2 for P and then for Q. And what happens here is you can see that the distance between these two then, if I can find the distance for the other two sides by just subtracting the x coordinates and the y coordinates, since it's a combination of a horizontal motion and a vertical motion, we can do the combination of those two things. So this is where the distance formula is derived from. So the distance on a coordinate plane, if you have horizontals, you can count, but the diagonals, you're going to use the distance formula. And I'm just going to show you that here. You're going to find the distance between the x coordinates and square it plus the y coordinates squared. And that is the distance formula. If I go back to the other screen, I can show you where these x1s and y1s come from. So to find that distance, that horizontal distance here of 3, if it wasn't 3, I would simply take the x1 and the y1 and subtract them. And then the x2 and the y2 and subtract them. And then I'd plug them into the Pythagorean theorem. So in the end, that's why we have things squared. That's your a squared plus your b squared. But then to get c all by itself, you have to take the square root of the whole thing. So I just want to go through this really quick and know that where these x1s and y1s are coming from is the first one's the endpoint of the first ordered pair, and the second one's the ordered pair, the coordinates of the second ordered pair. So what's nice about the formula is you don't have to make the right triangle. You don't have to worry about counting verticals and horizontals. You just plug these values into this formula. So let's go ahead and give it a try. So for the very first one here, I have the distance formula written up above. So you have your x1 and your y1, your x2 and your y2 here. So if we use the formula, distance is equal to the square root of x minus x squared plus y minus y squared. I don't even worry about the 1s and 2s. You just plug them in. Make sure you're subtracting the x's in the one and squaring it, and then the y's in the other. Usually order matters. I know in slope it matters, but in this case, the order is just going to determine if I'm going to square like a 5 or a negative 5. And so order really doesn't matter because when you square them, they both turn positive. So it's fantastic. So when I plug them in, I try to make the best decision. So I look at my two x values. I have a 3 and a 5. I have to subtract them. I want a positive value. I want to make it as easy as possible. So I'm going to do 5 minus 3. 5 minus 3 is going to give me a positive 2. And when I square it, I get 4. If I plugged it in a different way and did 3 minus 5, I would have gotten negative 2. But when you square negative 2, you also get 4. So order really doesn't matter how you plug them in, as long as you're plugging in the two x's and then the two y's. So for my two y values, I'm going to plug in 1 and 2, but I'm going to do it 2 minus 1 squared. So make sure you show me that step that I see before you even do any math, what you're plugging in. The next step is you're actually just doing the subtraction. So this will become 2 squared plus 1 squared. Show me that before you square it. The next step is just actually squaring it, 4 plus 1. And the distance then is the square root of 5. You can leave it just like that. Obviously, if we need to simplify, we would, but no decimals. Let's try the next one. So I have an x here and a y here, an x and a y here. Sometimes it helps just to put those designators above them. So distance is equal to x minus x squared plus y minus y squared. The more you write it down, the more it's going to become memorization. Distance equals the square root of, I'm going to actually, I have a 0 and a negative 3. If I subtract a negative, it turns positive. So I'm going to put the negative 3 last. 0 minus a negative 3 becomes plus 3. And my y values, I have a 5 and I have a 2. So I'm going to do 5 minus 2 squared. So unlike slope, it doesn't matter what order you plug them in. If you plug them in one way and then flip it, it's okay. And so we get 3 squared plus 3 squared. So my distance is equal to the square root of 9 plus 9. My distance is equal to the square root of 18. I apologize, my board is acting up. Number 3, one more time here. We use a distance formula. The distance is equal to the square root. X minus x squared plus y minus y squared. The distance d is equal to, I have my x value 7 and negative 3, so I'm going to do 7 minus a negative 3 becomes plus. And then I have negative 1 and negative 4. I want to subtract the larger negative. Negative 1 minus a negative 4 becomes plus 4, and that makes it positive. Again, it doesn't really matter because we're squaring, and so our signs will not matter. Distance is equal to 10 squared plus 3 squared. Distance is equal to 100 plus 9. So my distance here is the square root of 109. And actually, I just recognized that up above I forgot to simplify. When I look at the square root of 109, I got to quickly look to see if there's any perfects living inside it. And I don't believe there are. But I forgot to do that up above. So for the square root of 18, I should have taken out a 9 and a 2. And so it should have been 3 root 2. Always look for simplification. For this last example here, okay, it's a vertical line, so I just wanted to reinforce if you have a vertical line, just count. So you start at the top and you go 1, 2, 3, 4, 5, 6, 7, 8. It is 8 spaces. Okay, you can start from the bottom and count up, but you're counting the spaces in between. So I like to loop, even though my pen was not quite on the line. Same goes for horizontal. You can just count for those. Don't make it more work than necessary. So your lesson summary here is, how do you find the distance of a vertical line and find the length of the line with those two endpoints? Good luck.